Continuing with our lichens, we have about 25,000 known species of lichens. And this is probably the kind over here on the right that you've seen before, because this is the kind that grows in the environment that we are in. But you can find lichens in some of the harshest environments on earth. They're very, very sturdy because they can survive drought. And a lot of them live in temperate areas, which is what we live in. And then a lot of them live in the Arctic. They are called bioindicators. Now, what a bioindicator is it's going to be an organism that is very sensitive to change in environmental conditions. So ecologists, when they want to know if there's air pollution, what they'll do is they look at the lichens, because lichens are very old. And if the lichens are start to get sensitive to the air pollution, then they start to die off. And this is always an indicator of our air quality. If this were an animal, it would be frogs. Frogs are very sensitive, so they use frogs as bioindicators. So in times when ecologists go into rural areas, now they're not going to do this within the city because there's more pollution in the city, obviously, than there is going to be in more rural or country areas. So they're going to go out into the forest. They're going to start looking at the lichens, and they'll start noticing, the health. And if it looks like that they're doing well, then they know that air pollution is okay. And if it looks like that they're starting to die off or that they're not doing so well, then this is an indication that there might be too much air pollution. So they're powerful, powerful bioindicators. So lichens also produce some very unique chemicals, and they use them a lot of times in pigments, and sometimes they have some antibiotic properties as well. So overall, lichens have got a very powerful positive usage in our environment. Now let's talk about mycorrhizae for just a minute. Mycorrhizae is a mutualistic relationship between a fungus and some plant roots. Not all plant roots have them, but only some plants do. Maybe most of the ones that we're familiar with do, because more than 80% of our vascular plants, those are going to be the ones that we're most familiar with. Non-vascular plants would be plants that have to live in water, like our mosses, but most of the plants that we live with are vascular, and they have this fungus on their roots. And what the fungus does is it provides the root, it provides the plant with nitrogen and phosphates, and of course the plant is producing it with sugar. So in this relationship, it keeps you from having to use a lot of fertilizers, because naturally this fungus is going to break down. A lot of fertilizers are high in nitrogen, and so the more we cannot use them, the better off it's going to be for the soil. So they're very, very good with returning a lot of nutrients to the soil, as most fungi do, and giving it to the plant. So the plant usually has better growth, and the plant's making sugar to give to the fungus. So all of our phyla do have some sort of mycorrhizae. So there's not just going to be one particular fungi phyla that it's isolated to. And they think that during evolution that this type of fungi actually, or there were some types of it that actually co-evolved with the plant. Because if you're replanting something or you're repotting something, let's say your parents go and they buy a flower or something at Lowe's or the nursery, and they need to put it in a bigger pot, you need to make sure, a lot of trees have root balls, so you need to make sure when you're repotting those that you always put the soil that it came with in the transfer, because if the soil falls off and you just replant the plant, then what happens a lot of times, the mycorrhizae will go with the soil, and then the plant's going to die. And I've done this on more than one occasion. I've actually planted a a young tree, and the root ball just kind of fell apart. And I thought, well, that's no big deal, but it was, not realizing that that plant needed the mycorrhizae that was in the soil in order for it to grow. So you always have to transplant something with its root ball or its dirt. Now, the relationships are beneficial to both, so this is mutualistic. Here's sort of a close-up of what it looks like. And not only is the fungus boosting the growth, but the enzymes that the fungus releases are very harmful to a lot of bad bacteria. So the plant is able to grow and be healthier and doesn't get a lot of bacterial infections, so you don't have to use a lot of fertilizer and you don't have to use a lot of pesticides to kill the pests off. So it's a really mutualistic, good for both partners type of symbiotic relationship. So for the most part, fungus really do have a good effect on human lives. They're decomposers. We use them in medicines. Of course, we have them in foods. Here's some of our medicines. One of the most important is cyclosporin, which I'm not sure is up here or not, but it's what you give to transplant patients to keep them from rejecting other organs. Oh, here it is. This is a scientific name for cyclosporin. So we have penicillium. This is an ascomycota. It's penicillin. That was our first antibiotics. Claviceps purpureae. It has a really makes a good medicine because it reduces high blood pressure. A lot of people's high blood pressure medicine actually has this fungus in it. It can also control excessive bleeding, so they use it for hemophiliacs. It can treat migraine headaches. And they use it to, a lot of times, to promote contractions in women when they need to induce labor, or when the woman goes into labor and she's not progressing like they should, then they'll give it to her. Polypocladium inflatum. This is your cyclosporin for organ transplants. And rhizopus, this is your black bread mold, can cause chemical transformations of specific chemicals to make cortisone. And they also use it to grow a lot of things. Like, it's easier if you have got something, a medication that's expensive, they can use it to grow. And so rhizopus is good for anti-inflammatory drugs, rashes, any kind of medication that they're given to arthritic patients to reduce their joint swelling. So those are some real positive roles that fungus have.